I'm going to explain this project. First, my topic is shortest job first, non-primitive introduction, operating system scheduling. The process scheduling is one of the function of an operating system. In a modern system executes the thousands of process, and the CPU must be decided which process is run next. Since the system performance depends heavily on the correct scheduling, OS designers use the algorithms to improve the CPU utilization through the waiting time, response time, and the turnaround time. So first, shortest job first is a non-primitive. Selected the process which smallest burst time among the all process that have the arrived. Non-primitive, once the process starts its run until the completion, and obtain the average time, waiting time, and simple efficiency for batch system. And shortest process keeps getting the selected, causing long CPU bond and process to wait identify. And experimental steps. Experimental steps, we use the programming language C program language. And reason for the using C programming language is low level control and fast execution, easy to stimulation of the OS behavior. And tools are GCC compiler and VC code. Data set description, uh, we have the arrival time, rest time, and IO ratio, and PID. So CPU execution time is needed to burst time, and when the process is enters the ready to in the queue in a arrival time. So next, optimization technique. The reduces the strategy reduces the efficiency of the burst time gradually. This makes the longer wait process more likely to be chosen. In this way, the code will be again is stimulated. So next is um, implementation steps. In the implementation step, first input is initialization, and read the number of process in the code, and read the arrivals time and burst time and IO ratio. And auto signaling PID is initializing wait and maintaining completion of array. And apply the shortest job first in a non-primitive. Add the arrival process to read ready released. Apply again reduces the variation. Select the process with the smallest efficiency, the breast time, and execution to complete the non-primitive, and update the wait of turning time. The print process finishes the table, and table waiting time to turnaround time complete the average values, and displays how the it will show in the line. So next is flowchart. First in the flowchart we going to explain first starting program, and read the number of process, how many process are in the it will reads, and read the arrival time and rest time and IO ratio. Classifies the CPU and IO based on the IO ratio. Time is equal to 0, it will done, and click ready process arrival time, and apply again reduces effective burst for a waiting process. Select the process with a minimum effective burst time. Run the process in non-primitive. Update the WT and TAT marks in complete. Done is equal, if it was done, n is number of time. Yes, stop the else of loop, and it will displays the result code. um, In this code, we used the C programming language. First, the program task, then the reach the process, and user enters, and the values are shortest in structure called as process first, and second CPU bound or IO bounds classification depending on the IO ratio, and this stores in the type. And effective burst time, and again during scheduling each process waiting in the ready of queue gets, this again reduces the waiting time of long jobs. And third one is scheduling logical loop. Select the process and arrival time, and the current time is effective burst in the smaller, then the process will be take a time, and if the process is found and run until completion, and turn under time and finishes the arrival time waiting time and rest time makes the process and completes this code explanation in the, and output is entire the arrival time and rest time. First we selected the entire number of process is 4, and first process number 1 is waiting time is 0 and arrival time is 2, and waiting time is 4, and waiting time third process waiting time is 8, and fourth process waiting time is 3. And this all by doing calculation average waiting time is 3.75 and average turnaround time is 8.75. So this is the output of this code. Gantt chart is in this Gantt chart first P1 is processes and the second is P2 and P3 and P4. First P1's time is 0 and P2 time is 6 and P3's time is 8 and P4 time is 16 and complete time of P4 is 20. So this observes the average waiting time and average running time. The comparative evaluation without result in summary. Comparative evaluation is without aging. PID, process 1, process 2, process 3, process 4, and the waiting time of process 1 is 0, process 2 is 4, process 4 is 14 to 20, and process time waiting time is 2 for, and the with aging is process 1 2 3 4, waiting time is 0 4 8 3, and the resulting is the pure shortest distance is high in the average weight is higher and fitness is lower non and lower high. So comparative evaluation table in the data set,
ನನಗೆ ಗೊತ್ತಿಲ್ಲ ನಾನು
average
ಇವೆಲ್ಲ
waiting
ಮಾಡ್ಸಲ್ಲ.
time and average turnaround time context the switches and remarks. So first P1 is equal to 0 6 0 2 0 comma 2 and 2 2 comma 5. This average and waiting time is 5.50 and 10.25, context switch is 3 and CPU bounded with the suffering high time. In this second one data set is the average time is 3.75 and the average turnaround time is 8.75, and context which is 3 and remarks are distinct presents the CPU time P2 gets the profile, and data set is higher in this also, and 6.2 11.9, and it has this errors. This is the process like that only it will process the all. And the conclusion of this assignment is this is demonstrated the designing and optimizing of a non-primitive SGF scheduling capability of automatically identifying CPU bounded and 10 bounded process based on the implements again mechanism effectively prevents the starvation and the excess the longer CPU burn task actually receives the CPU time, and in this pure SGF produces the again based on SGF offers the balanced approach between the efficiency and fairness. This is the conclusion of this topic. Thank you.